In this video, we will cover 30 important interview questions and answers on loop testing for analog inputs and outputs. From pre-loop checks and signal simulation to HART communication, alarms, sequence of events, safety systems, and final sign-off, this guide is perfect for instrumentation commissioning professionals and interview preparation. What is the objective of classifying analog input types during loop testing? Classifying analog input types defines the correct loop testing methodology for each instrument. It determines the required signal simulation method, communication type, HART or non-HART, ADC pre-commissioning applicability, and loop acceptance criteria, ensuring accurate, safe, and specification-compliant testing. What are the loop acceptance criteria for analog input signals? Acceptance criteria define allowable deviation between simulated input and displayed value. PCS loops, plus or minus 5%. ICSS loops, plus or minus 0.5%. Tighter tolerance is applied for safety-critical systems to ensure higher reliability. What prerequisites must be completed before starting loop testing? All loop testing prerequisites and pre-loop tests must be completed and validated, including loop folders, approved documentation, calibrated test equipment, wiring continuity, grounding, insulation resistance, and system readiness. Why must the transmitter be isolated from the process during loop testing? Isolation prevents process disturbance, ensures personnel safety, and allows accurate signal simulation. This is normally achieved by opening the transmitter vent. What special precautions are required for DP cell level transmitters? During loop checking of DP level transmitters, the process must be isolated, the manifold equalized, no real DP applied, and zero verified to protect the sensor and ensure correct signal response. What site inspections are required before loop testing? Visual inspection verifies correct instrument position, tag nameplate, mounting, tubing connections, and ensures there is no visible damage or leakage. What parameters must be verified on the ICSS or DCS faceplate during loop testing? Verification includes tag number, range, engineering units, service description, alarm recording, alarm priority, SOE, alarm text, alarm setpoints, graphics, and dynamo. Why are graphics, animation, and primary display links verified? To confirm correct instrument representation, animation, scaling, and one-click navigation to the correct process graphic as per the functional design specification. What checks are required for PLC or UCP-based instruments? Checks include PLC or UCP communication with DCS, control system configuration, HART multiplexer communication with IMS, and verification via ICSS faceplate or PLC or UCP HMI where applicable. What configuration details must be verified in PLC or UCE systems? Engineering units, tag name, range, graphics, description matching the I/O index list, and alarm configuration as per vendor standards. What is hysteresis and why is it verified during loop testing? Hysteresis, dead band, prevents alarm chattering due to minor signal fluctuations and ensures compliance with the alarm management system. What are the standard hysteresis, dead band values? Flow, 5% off span. Level, 5% off span. Pressure, 2% off span. Temperature, 1% off span. What range and display checks are performed during loop testing? Minimum process value, range scaling, instrument position, animation, and correct HMI indication are verified. What is done if the minimum process value cannot be simulated? The dead process band value is simulated according to predefined hysteresis values to validate indication and alarm behavior. Why are step tests performed at multiple percentages? Step tests at 0%, 25%, 50%, 75%, and 100% and return, verify linearity, accuracy, scaling, and system stability across the full operating range. How are DP cell and pressure transmitters loop tested? By injecting pressure using a hand pump or pressure calibrator. The resulting 4 to 20 milliamps signal is verified at DCS or IPS with configuration checked using HART or AMS. Why is HART communication important during loop testing? HART enables verification of configuration, range, damping, diagnostics, and sensor health without disconnecting the loop, and confirms digital communication with DCS or AMS. How are flowmeters tested and why is actual flow not used? Flowmeters, mass, vortex, Coriolis, electromagnetic, are tested using 4 to 20 milliamps signal simulation. Actual flow is impractical and unsafe during commissioning, as loop testing focuses on signal integrity rather than process performance. How are capillary diaphragm seal transmitters tested? They are tested by pressure injection using a calibrator, with HART checks performed carefully due to capillary sensitivity and vendor project limitations. How is valve position feedback tested? By performing a full valve stroke from closed to open and verifying feedback scaling, indication, and HMI response on the DCS. How are RTDs and thermocouples tested, and why is ADC not required? RTDs and TCS are tested using simulators that inject equivalent resistance or voltage. ADC loop testing is not required as validation is done through simulation and calibration. How are motor, vibration, frequency, and pulse signals tested? Motor signals are generated from electrical panels or test racks. Vibration sensors use vibration simulators with fault checks. Frequency and pulse signals are tested using frequency generators. How are gas detectors tested during loop testing? Gas detectors are tested by injecting calibration gas or test tubes as per Fire and Gas System (FGS) procedures to verify alarms and system response. How are analyzers, CEMS, and level instruments tested? Analyzers and CEMS are tested using 4 to 20 milliamps simulation and HART verification. Full calibration is done later. Radar, capacitive, and nucleonic level instruments are tested using signal simulation or vendor procedures without ADC loops. How are hardwired PLC analog signals tested? By injecting 4 to 20 milliamps or 0 to 24 volt DC signals and verifying correct indication on the DCS HMI. How are alarms and SOE verified during loop testing? Low, very low, high, and very high alarms are simulated, annunciation is checked on graphics, and SOE records are verified for accuracy and timestamp correctness. How is out-of-range and bad PV behavior tested? Out-of-range behavior is verified by confirming no alarm between 3.8 milliamps and 20.5 milliamps. Bad PV is tested by opening knife-edge disconnects to simulate signal failure. What are common invalid signal causes for I/O types? DI card fault, I/O bus fault, TO card or channel fault, I/O bus fault, AI card channel fault, open circuit, less than 3.8 milliamps, short circuit, greater than 20.5 milliamps, AO card or channel fault, I/O bus fault. Why is ADC loop testing not performed for IPS, TIPS, analyzers, and CEMS? These systems are safety critical or process dependent and require real process conditions for final validation. During loop testing, only simulation is permitted to avoid unsafe conditions. Why is documentation and sign-off required after loop testing? Documentation ensures traceability and formal acceptance. Completed check sheets are signed by MICC, vendor, if applicable, commissioning authority, and client witness. Thanks for watching. Please subscribe, like, share, comment. IIQA